The next thing we'll do is we'll use multi-factor models to attribute realized returns to different priced factors. And so the idea is at some point in time, I observe a return on a stock or a portfolio, and I know that this stock or portfolio is affected by the market, and it's affected by oil, or maybe it's affected by cotton or corn or currencies or something, and I want to know what it was that caused the return to be what it is. To what can I attribute this realized return? And so here's the process that we'll go through to think about this. It is today, it's time zero. And what we're going to do is we're going to look at 5 years worth of historic returns to establish a baseline for these factors. And so we'll use multivariate regression to estimate the relationship between the portfolio or asset, whatever it is we're looking at, and risk factors that we think are important. So we can look at the market, we can look at commodities, we can look at style, we can look at economic trends, and these factor loads or betas can be positive or negatives, and we might also identify to see whether or not there was alpha in the past 5 years as well. So it's still time zero, we've identified our betas, but now we can use our factor relationships or factor loads and the expected factor returns to calculate the expected return of the stock or portfolio over the next year. And then finally at time one, this is the third step, we've now realized returns. We can examine the realized returns of the asset or the portfolio, and we could compare it to the expected return at time one. And so we can calculate the return surprise, essentially. We expected 10%, but we actually got 12. And so the realized return at time one, the expected return at time zero, we get this 2% difference. And we can see to what we would attribute this. We can look at our factors. So if I expected the market to be up 8 and the market was only up 7, so if the realized factor was 7, but the expectation was 8, then I can see that this was actually down. I can multiply this times the beta to see what the effect would have been on the stock. And what we can do is after we've attributed all of the returns to the things that are in the model, everything else is going to be essentially idiosyncratic, unique. Things that weren't attributed to the model must be attributed to these other factors, anything that's not in the model. So here's an example, and this is using data that I made up. So it's now today, time zero, and for some given or company or profile, we're going to pick a model. We're going to choose factors, and we're going to choose just the market and oil for simplicity. Technically, we should probably also include SMB and HML because we know these are generally price factors, but for the purposes of this, we'll just include oil just to make it a little bit simpler. And so here's our regression model that we're going to estimate. We're going to have the return of our stock or portfolio is going to equal alpha plus the market beta times the return of the market plus the oil beta times the return of oil. And we're going to run our regression, and here's our hypothetical regression results. And I can see that I have a coefficient, an intercept, an alpha, that is not statistically significantly different from zero, so I can ignore that. I have a market beta, which is 1.2. This is positive and significant. Okay, so that's going to be in my model. In addition, I have crude oil, which is negative and significant. Okay, so when the price of crude goes up, the value of my stock goes down because I have a negative beta. And so let's just very quickly look at these results. We can see that the alpha is 0.5% per month, but it's not statistically significantly different from zero because the p-value is greater than 0.05. And so we would conclude that there is no risk-adjusted excess return. I have a market beta equal to 1.2, and so the market factor is significantly different, statistically significantly different from zero because I have a p-value less than 0.05, and so I would include that. And oil is statistically significantly different from zero. It's negative, and because the p-value is less than 0.05, I know it's significant. So it's still time zero, and what I want to do is I want to use the betas and the expected factor returns to calculate the expected return of this particular stock. And let's assume that I'm looking at average returns, and I see that the average return of the market has been 10%, so I expect the market return to be 10%. I expect the return on oil to be 4%, and I have a risk-free rate of 2%. So I plug these into my model. Here's my risk-free, here's my beta, here's my market minus my risk-free, here is the beta for oil, here is the oil minus the risk-free, and I get an expected return of 11%. And so given the expected return of the market minus the risk-free, and the beta of the market, and the return of oil minus the risk-free, and the beta of oil plus the risk-free, I would conclude that this stock has an expected return of 11%. Okay, the third thing, it's now time 1, and so time has passed. So I was at time 0, and I calculated my betas over this time period. Still time 0, I calculated my expectation over the next year. Now I'm at time 1, and I want to see to what I can attribute the realized return. And let me just go back to where I was, and here's what I get. Now, because I only have 2 factors in my model, there are only going to be 3 things to which I can attribute return. The first is the market, the second is oil, and the third is everything else. And so when I have some sort of surprise return, I can only attribute it to the things that are in the model and then everything that's not in the model. So realized stock return is 11%. Note that 13%. Note that I expected 11, but I got 13. The realized return on the market is 11. I was expecting 10, and oil was up 6. I was expecting 4, and so we can see our surprises. The market surprise was 11, which is what I realized, minus 10, which is what I expected, and so I had a 1% surprise for the market, and I had a 2% surprise for oil. Now, what does a 1% surprise do for this stock? Well, if the stock has a beta of 1.2, a market beta of 1.2, and so this is going to be 1.2 times this 1%, I'm going to get 1.2%. And I can see for oil, a 2% market surprise times a negative 0.3 beta is going to be a 0.06 surprise. And so I can see that my realized return at time 1 is going to follow this equation. The realized return minus the expected return, which is the 13 minus the 11, is equal to the beta times the market surprise plus the beta of oil times the oil surprise plus the E. And I know everything but the E. That's pretty much what I'm solving for here. And so I can conclude that the 2% surprise in the return of the stock is attributable to a 1.2% market effect and a negative 0.6% oil effect, and so therefore I take the 2 minus the 0.012 plus the 0.016 and I get 1.40 as everything else. And so let's just go through the recap here. The stock earned 2% more than expected. The market earned 1% more than expected. Given the market beta of 1.2, this should have added 1.2% to the stock's return. Oil earned 2 more. Given the negative beta, this should have subtracted 0.6% from the stock's return. So the stock should have earned the expected times the market factor. It should have earned 11.6. But since it actually earned 13, I have this 1.4 unattributable, and that I attribute to E, which is everything else that's not in the market. In the model. And this could be manager skill, this could be luck, this could be anything else. And we'll do more examples like this for homework, but this is a very common application of a multi-factor model, is to afterwards see to what I can attribute returns.